Okay, so today I'm going to show how to derive the area of a polygon circumscribed around a circle. And we're going to start off with 3 polygons, one with 3 sides, one with 4, and one with 5. So the radii of the circles inside each of these are 1. And then you can check out the key, and just to clarify, r equals radius, n is the number of sides in a polygon, 3.14159 is our approximation of pi that we'll be using, and q is an angle measure. So, we're going to start by showing a triangle and kind of how to find the area of a circle, or a polygon circumscribed around a circle in a triangle. And so we're going to start by showing that this side length of the mini triangle is 1, and then gonna zoom in on this one little triangle right here. And so we know this is a 30, 60, 90 degree triangle because we split the 360 degree angle that's the circle into 6 smaller angles so that we can find this first angle right in here. And then that would give us 60 degrees for this angle, 30 degrees for this angle, because that's a 90 degree angle, so 180 minus 60 minus 30. And then, so we know that this is 30, 60, 90 degree triangle, and then we'll be able to find the area from that because, as you can see over here, the area of a triangle is 1/2 base times height. So since we know that this base is square root of 3, this base is square root of 3, and the height is 1, we would know that the area of this whole triangle is 2 square root 3. Or actually, sorry, just square root of 3. And so we know that for this triangle, but we don't want to have to do that for polygons that have like circles inscribed inside them, but have like 1,000 sides or something like that. That would be really tedious, and you wouldn't want to do that. So we're going to try to find the general equation. So zooming in on this one triangle right here, that's this triangle right here. And so we know we're just going to use this angle Q right now. And so we know that the rules of tangent, sine, and cosine show that the tangent angle is the equivalent of the sine over the cosine. So we find this value of this half length is actually tangent of Q because we know that the sine over the cosine equals the tangent. And then we want to find the area of the whole triangle in terms of this tangent here. And then, again, area equals 1/2 base times height. So we find that the area equals 1/2 to tangent of Q because we have 2 of these lengths right here times this. And then, since it's 2 tangent Q, 1/2 and 2 cancel out, and you find that area equals tangent of Q. Sorry, I forgot to write the Q there. And so we know that there are actually 3 of these triangles inside that circle, or inside the whole triangle with the circle. And so we know then that the area equals 3 tangent of Q. But I think we should solve further for Q so we don't have to find that for every single triangle or for every single polygon individually. So since we did this, and I explained that earlier, we know that Q equals 360 divided by 6 for this triangle. And then we find that that is actually equal to 180 over 3, which happens to be the number of sides that the polygon has, because it's a triangle, so it has 3 sides. So we can plug this in for Q in the equation that we just found. So we find that the area of a triangle circumscribed around a circle is 3 tangent of 180 divided by 3. And then we notice that the triangle actually has 3 sides, and 3 appears twice in this equation. So I wrote a formula for this, just kind of thinking of a pattern, that A could equal n, which is the number of sides, times tangent of 180 divided by n. And then I tried it out with a couple of these other polygons. and found that actually this was true. So we can use this rule to actually find the area of a polygon circumscribed around a circle. Like, this is a general rule that you can always use. And then just a side note, like in this table that I found, or that I made, we find that the number of sides and the area actually grow closer. They approach pi as the number of sides increase, because our approximation of pi up here is actually 3.14159. We find that 3 is 5.1962. A polygon with 4 sides would have an area of 4, etc., 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 until it gets down to about 1,000, 10,000, when you find that the approximation is almost exactly equal to the number of sides, and we find that this is true. I'll explain it in greater detail in the written part of this video, but we find that it actually does make sense, because as you can see, the polygon has more space here than it does here in a 3-sided triangle than in a 4-sided square. And then we find that the space between the polygon and the circle gets even smaller as the sides increase, which might give us just the beginning of the idea of about why the area can approach pi.